June 2013, Core 1, question 4. Long question, keeps on going and going and going. We start with the factor theorem question, so we're looking at what makes that 0, minus 3. So find out what f of minus 3 is, stick the minus 3 into the top there, and of course it equals 0. Don't stop there, say therefore x plus 3, a factor. Usual stuff. Now you've got to do the long divide. So we're looking at, I've done sort of big tables in other videos, so I'm just going to give you the answer to this one here. X times x squared gives the x cubed. We've already given that. That gives us the 3x squareds there, so I'm going to have to take away 3x's there to get rid of those. That would give me 9x's there, no, minus 9x's here, so I'm going to have to plus 5 there to get the other bit. And of course 3 times 5 gives the 15 that we wanted. If you need more explanation of that, please watch a video for long division. But we now change topic. We're now going to differentiate it. Lovely. We're all very, very good at differentiating. Very rarely does anybody get anything wrong here. The power times by the power, and the power goes down by 1. You get 3 marks, 1 for each one. Show that the stationary points satisfy this. Well, of course, stationary points are when dy by dx equals 0. So we're just going to write 4x cubed minus this equals 0. Let's divide everything by 4, shall we? Dividing everything by 4 gives us this thing here. Oh, I recognise. I don't. Going to recognise that in a second. That's 6. Yeah, I do recognise that. Sorry, I do recognise that. It's what we were aiming for. Use the results above to show that the only stationary point occurs when x equals minus 3. Well, that's because that thing there is what we started with at the beginning. And from the beginning, we know that this factorizes to x plus 3 times by x squared minus 3x plus 5. For a stationary point, this equals 0. Well, there's clearly an answer here at x equals minus 3. And most people got that. But how can we show that there's no solutions here? And just writing no solutions isn't good enough. We need to actually show that there's no solutions here. The way we show that there's no solutions is to do a b squared minus 4ac on it. If there's no real solutions, this is going to be less than 0. And so most people forgot to do this. So throwing the value in there, b squared is 9 minus 4 times 1 times 5, and that makes minus 11, which is less than 0, therefore no solutions. A lot of people didn't think of doing that. I'm sure if we'd told to, they could have done. Now differentiate again. A couple of people accidentally differentiated this one. No, you've got to differentiate the one you had earlier. So 12x squared minus 16. And find out what happens when x equals minus 3. If x equals minus 3 in here, sticking in minus 3 in that, minus 3 squared is 9. 12 times 9 is 108. 108 take away 16 makes 92. And the last line for 1 mark, 92. Well, 92 is positive. And because it's positive, that tells you that it's a minimum value. And again, most people successful with that bit there. Long question, nice that it's all linking in. Mark scheme here, as we've done it. And there's a little bit here. Most people forgot to do this discriminant of the quadratic here. But the rest of it was fine.